Hello everybody and greetings from the Delta College Planetarium. My name is Brian and I'm here to bring you the next installment in our series about the constellations. Last time we examined Scorpius, the scorpion in the summer zodiac. This time we're going to visit the constellation next door. Find Scorpius in the early evening summer sky by looking for the distinctive fishhook shape low in the south. Follow the hook shape all the way to the scorpion's tail. From here, we want to jump to the group of relatively bright stars to the left of the tail. This group of stars has a distinctive shape, almost like something you might find in a kitchen. It looks a lot like a teapot. These stars form the base, the lid is on top, there's a spout on the right, and a handle on the left. This teapot shape is so easy to see that they are frequently just referred to as the teapot. But they are most of the constellation Sagittarius, the Archer. Sagittarius can be difficult to imagine because Sagittarius isn't simply a person with a bow and arrow, it's a centaur, half human, half horse. The teapot makes up the bow and arrow of the Archer. The 3 stars at the front form the bow, the 4 stars on top are the arrow pointed at the heart of Scorpius. The stars of the handle are the Archer's hand. The rest of Sagittarius is more difficult to see because the stars are relatively dim, in a dense part of the sky, and depending on one's latitude, some are even below the horizon. If you can spot the teapot, you have essentially found Sagittarius. Sagittarius occupies an interesting spot in the sky. From dark sight, it can almost appear as though steam is rising from the spout of the teapot. This cloudy haze is, of course, the Milky Way, and the spout of Sagittarius happens to be pointing towards the center of the galaxy. If you spend some time studying the Milky Way in the sky, you might walk away with the impression that it's essentially split in two, that there's a top layer of stars and a bottom layer, and they're divided by this band of nothing. But that's not really the case. That dark band in the middle isn't the absence of things, but the presence of lots of things, tons of things. This band is the shadow of huge clouds of gas and dust that orbit within the galaxy. That dust blocks light from the core of the galaxy from reaching us, so it's difficult to observe the core because the light that we're used to, the light our eyes can see, is blocked. So astronomers have to turn to other kinds of light. Longer wavelengths of light are not easily blocked by dust and gas. Thankfully, stars are quite hot, so infrared light can reveal stars hidden from sight. But even longer wavelengths, like radio waves, can pierce deep into the heart of the galaxy. Solve one mystery and uncover another. Something is shining brightly in radio light at the center of the galaxy. What could be the source of such energy? Follow-up observations and other forms of light reveal X-rays emanating from this area, and stars whirling around a point in space where nothing appears to be. These stars are moving incredibly quickly, so they must be acted upon by an enormous force of gravity, but one that remains hidden. This is the basic chain of reasoning that led astronomers to conclude that a massive black hole resides at the center of the Milky Way. The black hole has somewhat confusingly been named Sagittarius A star, even though it's definitely not a star. The orbits of stars around this black hole reveal it to have a mass about 4 million times greater than our Sun. The confinement of such a large mass in such a small area is the strongest evidence for the existence of supermassive black holes. In fact, no reasonable astronomer disputes the notion that a black hole lives at the center of the Milky Way. Black holes defy our intuitions about how the universe works. The mass of Sagittarius A star is so great, it warps space around it so much that objects clear on the other side of it are still visible around the black hole. The black hole doesn't actually block anything. The light from those objects is curved completely around the black hole. But there is an area from which no light is visible. At any given distance from a black hole, an object needs a certain velocity to escape the force of gravity from the black hole. If the object lacks that velocity, it will get pulled in. As you get nearer the black hole, this velocity requirement gets higher and higher. Eventually, the necessary velocity to escape the black hole exceeds the speed of light. Light is the fastest thing in the universe, so once light can escape, nothing can escape. And because no light is being emitted by this object, it appears black. It is the absence of light. The boundary where not even light can escape a black hole is called the event horizon. And this is the absolute limit in our ability to observe the black hole. Our understanding of physics precludes the possibility of observing a black hole any deeper than this. So the event horizon is what we are looking for when astronomers try to image a black hole. The first such image was captured by the Event Horizon Telescope project. That picture was of the supermassive black hole at the center of the huge galaxy M87 in the constellation Virgo. The hope is that the next black hole imaged will be Sagittarius A star. So if it's clear where you are tonight, go out and try to find the teapot of Sagittarius. And consider how fortunate you are to live during a time that we are just beginning to peel back the secrets at the heart of our galaxy. That's it for today. Next time we'll examine another constellation in the sky. This is Brian from the Delta College Planetarium, wishing you clear skies.